Hello, this is Ness Tilson here. In this short video I'd like to show you how to use Polyboard and its panel assembly functions to build a wooden framed paneling to make modular office separations. Now, though Polyboard is basically a cabinet design software, it's got some very useful functionality that can be used for building lots of different things and a vast range of woodworking projects. And one of these is its functionality to build simple framed paneling. So let's go into a new model and I'll show you how to actually set this up. It's very simple, and once it's set up it makes the whole sort of project really fast to put together, and you get some really quick, fast, neat visualization, 3D visualization, and of course, as usual, all the cutting lists and working documents to build this stuff. So let's go into a new project. Let's get rid of this project here. And let's have a look at, here we have some walls. These walls here, and let's say we want to build a project which just closes off this area here with some framed paneling. Well, how do I do this? Well, let's have the easiest thing to do. Let's get rid of this one, which is, well, no real use. Right, the easiest thing to do here, from the project, which is our floor plan, let's add a new cabinet. And let's just bring the cabinet in as it is, which is a box, and let's click twice on the cabinet, and let's set up some paneling using this cabinet. So here we have just a basic box, and the thing we need to do on this box, first thing we need to do is to get rid of everything that we don't need. So we just want one panel, which is a framed panel. So let's just keep the back. So we get rid of the top, and we get rid of the bottom, and the left side, and the right side. And now we only have the back. Now what we want to do is we want to make sure that the back is in fact not overlapping. There's no overlapping panels overlapping the back. So we're going to go into our libraries, in our methods, and our box full methods, and make sure, and like we can see here in our box full cabinet methods, we have here some recesses. So we have here that the top and the sides are overlapping the back by 15mm. Now we don't want this because we want just one flush panel, and this is going to annoy us. So let's get rid of these rules, and now we just have a back which is flush to the back with no overlapping panels. Click OK and apply this to my cabinet. Now, one other thing here, let's give the cabinet the right size. We want height, let's take 2.50 m, that's fine for me. It's going to give me a wall separation which is 2.50 m high. Width 1.20 m, okay, let's take 1.20 m, but the depth here is 600. What I don't want is, I don't want it 600, I want the depth to be the thickness that I'm going to, of the uprights that I'm going to use, wood that I'm going to use to build the separation. So I'm going to put in here 45mm, and now the thickness of the cabinet is 45mm. And let's click the back now. We just have a back here. Let's click the back and tell the back and say that we want to put an assembly structure on the back. So I click on Structure, Edit, and then go into Assembly. And here we have the dialog box, which gives us the possibility to create a framed and paneled structure for this back. Let's first of all put the assembly method to overpassing uprights, which means that the stiles will go over the rails and we'll be mortising the stiles and tenoning the rails. And let's give it a tenon. Let's give it a tenon which is 6 centimeters long, and let's give it 10mm wide, thick, and let's give it a shoulder, which is not really the shoulder of the tenon. In fact, the terminology here is not exactly right. We said the shoulder is in fact a sort of is the offcut, is the setback of the tenon. And let's give this the panels. Let's put a paneling in it, and I'll choose from my materials. And here I have I think I do have a beech 5mm panel. And now we're going to give some materials for the stiles and the rails. By default, we can give we can put the material type here. We have two choices. We have panel and bar. Choose bar and make sure that in the bar materials we have in the libraries, let's have a look at what we have in the libraries here. If I look in the libraries, we can see in the bar materials I've actually set up a material which is beech, 90 by 45 millimeter beech. So I'm going to click 90 by 45 millimeter beech, so that and I'm going to do the same for the other crossbars. So it's in bar, and I'm going to choose 90 by 45 millimeter beech, and this will give us the sections of the rails and the stiles. If I look into that's all the crossbars set up. Now let's have a look into the distance that this intermediary crossbar is placed, and from the floor. What I want is it to be 800 millimeters from the floor. So I'm going to go into the mode of positioning mode, and I'm going to take a distance from the bottom, and here I'm going to set up 800 millimeters from the flooring. And if I click OK, now Polyboard has actually created a framed panel. Let's have a look in the paneling. Here we have a framed panel, which is quite neat. We can set that up like that, but we could also now this frame panel will react like a cabinet. If I want to, for instance, set up a plinth on it, I just have to give an elevation. Let's put a 100 millimeter elevation on the bottom, which creates a plinth area, and I can put in here a plinth, play a plinth from the front, and let's say I want it 12 millimeters from the front, so that it would actually go in the middle. And here we actually puts a plinth on the bottom here. Of course, the plinth, I can give it the thickness I want according to the material that I've given to the plinth. So depending on the type of fixation that I'm going to use on the flooring, I will put in the plinth in function of that fixation I'm going to be using. Can be any section. And okay, so we got a panel here. Let's take this as a basic panel, which is quite good for me. And let's say that this particular panel, now, we're going to save it into the model, or save it into the project, shall we say, and we're going to call this paneling, panel 120 millimeters. It's 45 millimeters thick, which is going to be our standard thickness. But let's say we're going to call this full paneling. So we're going to call it full paneling. Let's call it full paneling. Full panel 120 mil. Okay, so now we've put into our project a model that's cabinet, which is called full paneling 120, which means that we have a panel which is made up of like this, with mortise and tenon joints, and it has full paneling with beech at the bottom and beech at the top. So let's put one in here, and we're going to clip it onto the wall, and let's have a look at how it looks. And here we have our full paneling. Pretty neat, eh? Right, we can continue putting in full paneling, but what we want as well, let's say what we want is, is to have a paneling with some glass top. So I go into my full paneling again, I click twice on it to go into edit mode, and let's say that what I want, this is a back, I click my back, and let's say, and when I click the back, I have all the different parts of the back which are listed in the properties. So let's take the central panel, the top central panel here, top, I click on it and change the materials to glass. Okay, now we have a paneling with glass. Let's have a look at what that gives. Okay, now we have panel with panel bottom in wood and panel top in glass. That's fine. That's exactly what I want. So let's save this too. Create a new model, and let's call this glass panel 120. I'm going to call it glass panel 120. That's fine. Call it glass panel 120. Now I have in my list a glass panel 120. Let's click that in place and see what that gives. And here we have a glass. We have a paneling, full paneling here, and a glass panel here, which is pretty neat. Right, now what we can do is we can go back. We go back into the project here. Now what we would need, for instance, I would like a frame to put a door in. So take a full panel. Let's take a full panel, and let's modify this to put a framing for the door in. First of all, let's get rid of the plinth. I don't want plinth anymore. Let's get rid of it. We don't want it up 100mm anymore, put it on the floor. And what we want though is we click on it, and let's get rid of the lower crossbar, which is the lower crossbar here, by putting its material as a nil panel. That is, the lower crossbar we've taken, say it's a nil panel, it's a virtual panel with no thickness. And let's get rid of the intermediary panels too, and we're also going to give them nil panels. So each panel is going to be a nil panel, just a virtual invisible panel, and that's fine. So we have here now an assembly with just the framing, and we want to put this crossbar at the right height so that we can put in a door. So let's go into the assembly and edit the assembly method, and let's put the positioning, the distance of the intermediate crossbar, no longer 800, but let's set it up at 2 meters, for instance, so we can have a 2-meter door. And now we have a frame, which is pretty neat. I mean, we've got a frame through which we can put a door. This frame is okay, but it's a bit narrow for the door, shall we say. So let's say we're going to put in 2 doors which are 800mm, and well, let's just say let's say we don't want it 120, let's make it 180. Let's click outside here, and the width, let's put it 180. And so we can put a double door in here, 180. So we have the actual door size, the width, total width being 180. That's fine. Let's keep this paneling and create this as a door. I'm going to call it a frame, and I'm going to call it 180, frame 180. And now we have frame 180 here for putting in a door. So let's set up the door. Okay, now we have the frame which is ready to receive some doors. So how do we make the doors that go into the frame? Well, let's have a look how we make the doors to make the frame. The best thing to do is to take the frame, click on top frame, and put it into edit mode. Now this frame is a box, but it's only got the back, and this back has an assembly, is assembled with a frame and panels. But what we want to do is now we're going to use a virtual box which we're going to put some doors onto. We're going to use the frame, so let's say, but in this particular, what we want to take back now is we want a right side and a left side, so we put the sides back onto the box, but we don't want the back anymore. Let's get rid of the back, no back, and now we just have a space, a virtual space with a right side and a left side. This right side and the left side, I'm going to click on the right side, for instance. The material is default material of beech, but I'm going to put another material on it, and this material is a material I've made it on purpose, which is a material that has the thickness of the width of an upright of a stile. So the width being 90, and this material I've called it ZZ nil 45 by 90. That means that the thickness is going to be 90, and so it's going to fill up the space. And I call it ZZ nil because I've given it a transparency of 100%. So it's going to be a virtual material like nil panels, which have no thickness, but this one's got a thickness. So it's going to space out the door size so that it's going to be as if we're putting in a door, which is minus 90 with 90 thickness material on one side of the cabinet. So let's click on that, and here we have 90 material, and let's do the same thing for the other side. We're going to give it material ZZ nil 45 by 90, so we have 90mm width, and now we have a cabinet which has no back, no bottom, no top, just 2 sides, with virtual material which is the same width, or it's the same thickness, this virtual material, as the width of my stiles. This enables to give us a volume in here which is just the right size to place a door. Let's click on this volume and add some doors. Add a door. Let's have a double door. And now we have a double door in default material, which is 19mm, which is overlapping our sides. We don't want it overlapping, so let's take the parameters and let's say applied globally, we put it built in, so it's between, inside our box. And this is fine. I mean, let's have a look how it is. Here we have virtual door. We cannot see the uprights because the uprights are in fact invisible, 100% transparency. But they are there to put the door at the right size. Now what we want is the structure on the door. The structure on the door, what we want as a structure, is the same structure as we had on the back of the other paneling. So let's take the glass paneling. We click on the back here. Hang on, let's get on the back. Okay, now we've got the back is selected with its structure, the paneling with its structure. Let's right click and choose copy the structure. So we copy this structure into the memory of the machine, of our computer. We go back to our framed frame 180 here and click on a door and right click and copy the structure onto the door. Oh, sorry, I copied it. Let's paste the structure. Sorry, I'm going to go that again. Take the glass paneling. We're going to glass paneling and copy the structure, and here on this one we're going to paste the structure. Now we've just taken the structure and pasted from the glass panel that we made previously, and we've pasted it onto the door that we've made just now. And let's paste it onto the other door too. If we can click the other door, let's just click the other door here, door 2, and let's paste the structure onto this one too. And this will give us, let's get rid of our glass paneling which we haven't used, and frame 3D, and now we have two doors without their framing, with the same structure, the assembly structure that we have on the paneling, the glass paneling. So let's save this now, and this will be saved as a new model which we will call double door. I'm going to call this double door 180. And now if I take the double, it appears in the models list. Let's take the double door 180 and let's clip it onto the framing, and we see that we have here now a double door. But note that the double door, I forgot to change the height of the double door. That's no real problem because I simply click and put the double door into the editing mode and give it the right height, which instead of being the same height as the paneling is going to be now 2 meters high. And if I go back into our, and this time I will save the model, save it in the actual model that's in the project, and we now have the doors which fit neatly into our project. So let's just finish this off here and show you a bit how, just show you quickly how supple this way of building wall separations is. If I put in now another glass panel here, that's great. And now we say we want another glass panel to fill off this section here. Let's just clip it onto the wall here, turn it around here. Let's take the measuring tool and take the distance from here to here, 455. Take this element here and give it the width that we need, which is 455. I'll create a model here, glass panel no longer 120, 455. As well as, let's take the measuring tool here, the distance between here and here is 140, so let's take this particular panel here and give it a 140 depth. And this time we'll create a new model and I will call it 140. And here we have now so here we have our project now completely set up in 3D, Of course, the interesting thing here is that we have all the cutting lists here of every single material, and all the cutting lists as well. As we've used bar material for the framework, we have the cutting list of all the bars. This cutting list can be automatically output into OptiCut. So if I click in the OptiCut export function of Polyboard, and we open the file, let's replace the file that we've already made here, just give the default names for each element, and OptiCut, it automatically opens and reads the list, and here does cutting optimization of all the bar material. Here we have all the bars. We're asking OptiCut to optimize to lengths of 5 meter 10, and here we have all the bars optimizing on 5 meter 10. We can optimize all the panels. Let's import the same file and ask them to optimize all paneling. Now the optimization shows here, for instance, that all the panelings, the beach paneling has been optimized. The glass has been optimized because we have a material which we put into OptiCut, which is glass. But the ZZ nil, of course, which is the virtual material we're using to put the doors at the right size, is not at all optimized because we do not have any sheet material that corresponds to the ZZ nil, so that it's not optimized at all and is not counted in the cutting lists. So let's see what the cutting lists give. Here we have the cutting maps of the paneling. We have glass, beach, we need 2 sheets of beach, 5mm beach for the paneling, and we need, this is the plinths, which is cut out of 20mm, I think, plinths. So everything's optimized. Go back into Polyboard, and any change in our project will automatically be given changes into our cutting lists, and we can re-optimize and get different optimization and prices, etc. So that's very quickly how to use Polyboard for building wall separations. Thank you very much for listening, and I hope that's been of interest to you, and that we'll see one another again soon in another video. Thank you, goodbye.